Let's try it again. Hello and welcome to John Park's workshop. I'm John Park and now my mic receiver is on. Hey! So it's hot today. Someone mentioned it was hot where they are. It's hot here, so I've got the AC running. And hopefully that sound isn't too terrible. Oh, you can hear my audio alert thing going there. Thank you for that. I think we're all set now. So let me know in the chat. Speaking of the chat, we got people over in Discord. So hello to all the good people of Discord. Mr. Certainly, Boop Games, Andy Calloway, Mr. Certainly again. You're there twice. Hello, C. Grover. Hey guys. So we're gonna kick this thing off if we've got audio levels working now. And I'm waiting for, let's see, we've got in the chat, C. Grover is, I think, about to tell us how the audio levels sound. I'm going to guess they're a little low, actually. Let me bump this up a little bit. And again, hopefully that air conditioning noise isn't too annoying for you, but I'm afraid that some of my cameras are going to overheat, which is the, I can take it, but yeah. Okay, good. The HVAC is negative 36 dB, says C. Grover, so thank you. It's good to have experienced audio people in the chat. Hi, Ardana in the YouTube chat and Mario Ortega. Audio is okay. Well, thank you. Thank you for that. All right, so let's get going. First of all, I'm going to mention we've got a jobs board, and you can use it to find a job. You can use it to post a job, and you can do all of those things for free. And that is at jobs.adafruit.com. In fact, there it is, right there. That's jobs.adafruit.com. And if you scroll down in here, you're going to see some postings of jobs that are available. No one has taken this gig yet, right? Animal ear emulation. This looks like a cosplay thing. That was mentioned on Ask an Engineer last night. Also, application development BAS program full-time instructor at Renton Technical College in Renton, Washington. That looks interesting. It's a contract gig, I'm guessing in person, but who knows? Check it out. Yeah, it's a full-time tenure track position. So anyone in Renton or interested in moving there, you should have a look. So that's jobs.adafruit.com, and it's free, so check it out. Now, I will also mention at this point that we have a coupon code that you can use in the Adafruit store, and that's going to get you 10% off on anything you want to buy that's a physical good. So this is not good for software or gift certificates or for subscriptions. But if you use Pedal Power, today's coupon code is Pedal power, that will get you 10% off over in the Adafruit store. And I encourage you to go and have a look. There's lots of great stuff. We're going to do a few different little projects today that involve some Adafruit parts that you might want to check out in the store, and that'll get you the 10% off on checkout. In fact, that brings me to my product of the week. And my product of the week is this little guy. This is called the Plantagotchi, and that's for Circuit Playground or Circuit Playground Express. And I'm going to pop over to my workbench camera here so we can have a look at the Plantagotchi and a little something I made with it. So there's your Plantagotchi, and this is essentially like our Perma-Proto boards. It's got prototyping space where you can solder on components. It has a power rail and a ground rail, and then it has dedicated pads for all of the pads that are normally on the Circuit Playground or Circuit Playground Express. So there's your Circuit Playground. And if you want to solder together a little circuit or a breakout board, this is a really great way to do it. You can see here, I have a little example where I've buried a little battery between these two boards, and then you just use the included screws in order to connect your Circuit Playground Express to the Perma-Proto or to the Plantagotchi, and that makes both a mechanical connection as well as an electrical connection between those pins that you're using. I've just screwed all of those screws in, so it comes with 12 screws, little M3 screws. And you can see here I've got this little bicolor LED matrix that is a breakout board that we also sell, and I've soldered that onto the Perma-Proto, and then I've wired that to the appropriate pads on my Circuit Playground Express. So I've also got some buttons on here, and I haven't connected these to anything yet. I've soldered them into essentially some blank pads, but they're not doing anything yet. But I think this is a really neat way to move one step beyond the typical Circuit Playground project where you're going to have alligator clips connecting things, and things can come loose. So if you want to move one level up, and the sort of nice thing is you're not soldering anything to Circuit Playground or Circuit Playground Express, so you can unscrew that and ignore your Perma-Proto board and maybe have a collection of these that you can swap onto different Circuit Playground Expresses. So that's my product of the week, is that super cool Plantagotchi. And like I said, you can get 10% off in the store if you use that coupon code PedalPower. I think that might be out of stock at the moment, but you can set up a email alert and it'll let you know when that's back in stock. All right, so that brings us to, let me clear out some of these things here. Let's go to, how about, go to the Make Code Minute. So for the Make Code Minute today, pull up my Chrome browser here. In the Make Code Minute today, I want to talk about using maker.makecode.com and a Gemma board, the Gemma M0, in order to use the capacitive touchpads and the little onboard NeoPixel. So you can see I'm using maker.makecode.com. It's a little different than the normal Circuit Playground Express one. And this one supports a whole bunch of different boards. So I've created a project here. I've selected the Gemma M0. And then I'm using these input blocks, this on-touch block here. And I can pick from the different pins on the board. So I'm using touch 0 to set my... oh, hold on. We're seeing double vision of the face cam. Oh, we are. All right, let me fix that. All right. Which one is that? I'm going to start that over again once I clear this up. Where are you, thing? There we go. Woo! That's better. All right. You got to take two just because I want a nice clean edit of this. So here we go. Behind the scenes. So for today's Make Code Minute, I want to talk about using the Gemma M0 with maker.makecode.com. So normally we use makecode.com or arcade.makecode, but maker.makecode.com allows you to use a whole bunch of different boards. So in this case, I've picked the Gemma M0. And what you'll see here is that I'm using this input block section to pick the on touch, and then I'm picking the D0 pad as well as the D1 pad, and you can see them labeled over here in the simulator. And when I press the D0, we'll get the NeoPixel here turning blue. And when I press the D1 pad, you'll see I run through a little color sweep of the hue value using this index 0 to 255 block. And then when it's done setting those colors, it lands on this sort of pink color. So if I pop up my actual Gemma M0, you can see it in action here. When I press D0, it's gonna, oh, let's see, I gotta reset it. I think it's, there we go. And when I press the D0, it's gonna run through the color cycle, and when I press the D1, it'll go blue. Or I think I have those backwards. Yeah, D1 is going to the color cycle, and D0 is going blue. And so that is one way that you can use the Gemma M0 with maker.makecode.com. That's also one way that you can tell that this is really a live show, because I'm getting messages from Mr. Certainly right during the segment, helping me fix the segment. So thank you for that. Eagle eyes. I've got a lot of different layers here to pick from. So let's now move on for a moment. I'm actually going to plug in a different board here. I actually have a prototype, an old prototype Pi badge. It's one of these weird purple ones with a incorrect silk screen. So. And what I'm going to do is have a look at our Make Code Arcade Game of the Week. And the Make Code Arcade Game of the Week, switch the tab over here. So the Make Code Arcade Game of the Week is Dance Party Remastered. And this is by Shack Attack 8. This is in the Make Code forum, so forum.makecode.com. Actually, PT sent me an email and said, hey, check out this, this new game that's been posted in the forum over here. And if you click on that link, you can open it right up in the simulator. We get this opening screen with these two people here, and it says Dance to the Beat. And if we press A, it'll move us into the gameplay itself. And I'll do that for a second here, but I'm actually going to switch over to my actual Pi badge, because it's, I think, easier to play in the Pi badge than it is there. So I only got a score of 2 there. So let me switch to this view here with my Pi badge, and you can see here when I press A, I now can use the keys and buttons. So I've got the A button, up button, B button, right. So it's kind of like a Dance Dance Revolution type of game, or any rhythm game, except I can't talk and play it at the same time. And all right, we'll let it die. If you miss 5 times, it ends the game, and it gives you your score. So let's have a look at the code. I thought there was a pretty cool thing in here. So if I switch over to the actual edit view of the game here, you'll see I thought this was really a nice way to very gradually increase the challenge of the game. So you'll notice in the on-start block, there is a variable being created called pace. So it's the pacing of the game, and it's set to a value of 35. If we look at how that's being used, that's determining the velocity on the y-axis for all of the different elements that fall towards the little dancing characters there. And I think they're so cute. I love the 2 little characters holding hands and dancing. So that pace value starts off at 35. And what you'll see is that there's a on-game update every 2 seconds that changes the pace by 1. So it's going to very gradually, every 2 seconds that you play successfully, add a little bit of velocity to that. So it's coming down faster and the game gets more challenging, but it's not brutal. It doesn't come down super fast right away. So you have a chance to get good at it and then not get bored because it's getting a little harder as you go, which I think is a great mechanic for pacing a game. And so that's my game of the week, which is Dance Party Remastered by Shack Attack 8. And I'm also continuing to be impressed with the variety of the types of games that people are creating. So if you're getting into creating games in MakeCode Arcade, please go ahead and sign up over at the forum.makecode.com. I believe it's a discourse forum, so if you have a discourse login, you can go right in there and use it. And post your game, because there's a good chance that it will get looked at and maybe featured on the homepage, or it'll be a pick for the game of the week. So please post your work, and it's a really nice community over there on forum.makecode.com, where I see a lot of people offering critiques or suggestions, or people asking questions about how to improve their games or do certain things. Over in the YouTube forum, Christophe Buzzoni, I'm sorry, I'm butchering your name, says, with Daft Punk or Soul Train music? Yes, that would be fun to have a soundtrack on that. I hear there's some new stuff coming in the melody creation on MakeCode Arcade, so stay tuned to see what comes of that. So I think we could use a proper sequencer in there, which would be cool. All right, so let's see. I wanted to now talk about our project build for the week. And you may have seen some teasers of this. This is, I'm going to switch out devices yet again here in my downshooter. Actually, I've got a battery plugged in on this one, so I don't think I need to plug it into USB. But let me give you a little view of that right there. So this is a Pi badge, and it is running this MakeCode Arcade program that I created, which is going to be a plant sensor. So it's I'm calling it Plantagotchi, kind of like a Tamagotchi. So you have to care for your plant, and it's going to be not only a virtual plant here on the Pi badge, but it's also going to be a real-world plant with soil. So we're going to measure the wetness of the soil using a sensor, and also light. We're using the light sensor that's built right onto the board here. So the sort of evolution of this is, the first thing I wanted to do before I had any proper sensors involved was just work out the user interface. And so I decided I wanted to have a plant face that was pretty large on screen. So this is actually a 96 by 96 pixel sprite, and this is a 160 by 120 screen, so it's taking a good bit of the real estate. And I asked my daughter if she would help me with this project, because she's on break right now, and she's a terrific designer, so I wanted to ask her for some help with the design. So I told her that we wanted a sort of pixely style plant, and so you can see here she actually is using one of our notebooks that came in the last Ada box, a little gridded notebook. So she's created our basic happy flower, and she gave a little indication of coloring, so the yellow center and the pink petals. And then these are the different states that we wanted to have. Let me move this over so you can see the icons in the corner. So this is when there's too much heat, I think, or too much water. Yeah, too much water, and actually these ended up becoming blue. But it's this face going, oh man, I've got too much water here. Then this is one that is not enough water. Here's one where it's sort of on the upper end of the light meter. Not necessarily a bad thing, but we wanted to indicate that we have more than average light. And this is when it's less than average light, so we have kind of this sleeping character. And so what I did was I worked with her in a pixel art program, and I actually taught her how to use Sprite a little bit to create these characters. And then we brought them over into MakeCode Arcade using the asset tool, and there's a tutorial on that on the Learn Guides already about I think it's taking your games to the next level, and it talks about using the asset tool, which lets you use Photoshop or Sprite or one of the online pixel art creation programs, and then import that into the game engine. So the next thing we did was we created logic. So when I just want to test that those are working without worrying about the sensors, I've got arrow keys. Let's see, let me reset this. It looks like it's hung. Or I've broken something in the code. That's always a possibility. There we go. So you can see these changed a little bit. So this one's the same. This is our general happy face. This became our too much water. So the eyes are sort of squinting like, oh my gosh, I'm a little bit drowning here. And we've got the little blue marks on the face. And this is the not enough water. And that's that sort of dry face with the little wiggly mouth and some blush on the cheeks. Let me turn this at an angle. You'll be able to see the pixels a little better. And these colors are not quite true on the camera. Sorry about that. So then if I up arrow, up and down is the wetness, and then right and left is the light sensor. So you can see when we go to the right, either at a level 4 or level 5, we go to the sunglasses. And when we dip down to level 2 and 1, we get that sleeping. And then I created a combined set. So you can see if we go, let's say, to sleeping and dry, we get that face. Or sleeping and wet, we get that one. Sunny, wet, sunny, dry. So those are all of the different possible states. So let's have a look at the code just to see that much so far of how this is working. So let's switch back over to Make Code Arcade. Okay, so you can see here, once this loads, I'm gonna zoom out a bit actually so I can find the setup. So what I did was I made different functions for all of these different states. So let's just look at a couple. So this is the dark wet state, and so I have one sprite image. It's like one character in the game called plant sprite, and when this function is called, it switches the image over to, let me see if I can move that just a little bit. There we go. Oops. Where'd you go, Chrome? So there's this combined one for the dark and wet state, and we also have the sprites in the corner to show the little icons that indicate things. So here's our sunny dry, and I'll show you one more. Where's our happy state? I think I've just got that in the general make sprites. So that's how we are setting different sprites, is just by calling functions. So now, to call those functions, actually a couple of different ways that I'm doing that. One is I'm going to look for, if you get a complicated Make Code Arcade program or any Make Code program, you get good at searching for the blocks you need based on color. So I know that these button press blocks, are orange, and then I'm going to grab this one for looking at later. So these little ones here, these are my button presses. So you can see here when I press up, what I'm doing is checking the water level. If it's less than 5, just to make sure that I have kind of an upper limit that I don't go past, I will then change the water level by 1, so I add 1 to it, and I'll set the water level to the remainder of the water level divided by 6, and this is again just how I'm clamping it to not run over. So it's sort of like using modulo. I don't know that there's a modulo function inside of here, but it allows me to essentially go 1, 2, 3, 4, 5, and then the next number wraps around back to 1. So I'm doing that for up and down for the water level, and I'm using this left, zoom in a little, and right for the sun level. And same sort of thing. It's either less than 5 or greater than 0, so that we don't go too far below. The state of those is being considered when we look at these game update blocks. Let me pull all my purple game update blocks. I think I've got them all together right here. And you'll notice there's some work in progress stuff that I have sitting around. That's these gray blocks. I'm just going to move them out of the way. But you can kind of leave little, it's almost like commented out code that I have sitting around. So here's what happens. These are all running in parallel, and these are 2 that happen essentially at every tick of the game's internal counter. So really quickly, it's doing setting the water counter count to the water level. That's what's, I'm using that counter, that 7-segment counter, to have those numbers in the side there. And the other one that I'm using here is setting the sun counter to the light level. And now I have a new one that I'm just introducing that's going to use an analog read. So we'll get to that in a second, because that's how we're going to start using real world sensing. And then you can see I'm also using the onboard LEDs. So every 5 seconds I blank the LEDs out. I set them to black. And then I check the LED mode. And so it's essentially, am I looking at the moisture sensor value, or am I looking at the light sensor value? So it flips between 0 and 1. So the first state here, it runs through and sets the water level to blue. So it'll give me as many pixels as that 1 to 5 water level is at blue. And I'm correcting for the 0 index here with this -1. And when it flips to the other mode, it goes to yellow for the sun level. So let's flip back over to our device here. And if I hold this right, you'll be able to see, probably mostly with the reflection in my thumb there, but you can see the yellow. I got 4 pixels right now. And the blue, I've got 3. So if I drop that down, this will be 1 and 3. Okay, so that's every 5 seconds we'll get that update. Now, the next thing we'll do is take a look at these real-world values. So you saw on this one raw counter, the game update raw counter is counting the light level. And then I'm updating, you can see it actually, again right here, if you look at this bottom number, this is the light meter, which goes essentially from 0 to 255. And in the light right now in my workshop, I can get it down. Actually, it seems to bottom out. Yeah, I can't quite pinch it closed enough with my fingers to get below that 5. But that's me covering the little onboard light sensor right there, which is mounted on the back here. And then there's a hole. This is a really clever way that Lady Ada built the board so that we have that forward-facing light sensor. And so what we'll do, I don't think I have this hooked up right now, but what I'm going to do for the ultimate project is, rather than these little buttons to change the icons, it's all going to be based on what that light sensor is reading. So the face will be based on that. And then this other sensor here, you can see right now, it's reading about 500. And what I have at the moment for testing is I've just hooked up a potentiometer. And if you look at that, let me see if I can get you a little closer there. So if you look at that value, as I turn this potentiometer to the left, we get to about 0. It's a little bit of noise in there. And up at the top, it seems to settle really nicely at 1023. So that is what the analog read values on these, this analog read pin right here. So I'm reading, I think it's analog 3. And then to use the potentiometer, I have ground and 3.3 volts. And so this is acting as a voltage divider, and it's spitting out 0 to 1023 as the raw values. So what I'm going to do with that ultimately is, let me show you over on the workbench how this is going to get put together. All right, so, and sorry about that. I know this camera is wiggling a little bit because of my air conditioning is blowing on it, so sorry about that. Let's zoom out a little bit here. And so what I've got is a little potted plant. It is a fake flower at the moment because I didn't have a suitable plant. And what I'm going to use are a couple of nails and alligator clips. So these will go in to the soil, and then these are going to clip to those same power for a voltage reference and A3 for the analog read on the board, and those will provide us with a varying analog read value depending on the moisture level of the soil. So what we'll do is we'll calibrate it, and then we'll be able to set the program to know that some certain value is what we consider to be the baseline. And in fact, the MakeCode team, I was talking with Pelly about this, one of the guys on the MakeCode team, they did a project like this on the microbit, and it's been really popular in schools. They found, I think, a value of 500 tended to be their middle of the road reading for a good moist soil. and then anything that goes above that will trigger the too moist readings, and anything that goes below that will start to trigger the too dry readings on the software. So it's that simple. Now, we do also, as sort of a sneak peek, we've also got some plans. If you take a look over here at my Pi badge, and this would work for the Pi Gamer as well. If you look here, we've got these two 3-pin JST connectors, and those each could be used as an analog read. They currently aren't supported very easily in the MakeCode Arcade software, but that's coming. So we'll be able to do digital and analog reads and writes through these two JST connectors, which is really cool. And we have our stemma connector. So the stemma connector, oh, let me go to a different, that's that weird camera that I don't want to use. There we go. That stemma connector is very useful. It has a SDA and a data and a clock line, which can be used with I2C devices. So what I would like to do in the future is use, oh, I wasn't showing that to you. Sorry about that. Come back. There we go. So these two are the 3-pin connectors that we can use for analog and digital, and they have ground and power as well. And then this 4-pin connector will be able to use these stemma connectors to plug in devices, and this is one such device, which is our I2C soil sensor. It actually also, I think, does temperature. I think it has a little temperature sensor up here. So that'll be able to plug right in very neatly into the board like so. And then we'll be able to use a more sophisticated method, but it is actually pretty cool to do it just with the alligator clips and nails. So that's what we're going to do first. But since some of this is a work in progress for MakeCode Arcade, I didn't get the time. I just got this analog read working with the help of the Microsoft MakeCode team, and so once we get that settled, it'll be in nice, easy to use blocks. Last thing I wanted to show before we end, though, is how am I doing that right now when we don't have the use of any blocks for this. So this will dive sort of slightly a level deeper into the inner workings of MakeCode Arcade. But what we're doing is I've added in the extensions section, you can pop this up and bring in an extension. So I've added the feather extension. And so if we look in our blocks, we don't see anything. This extension's been added, but it hasn't done anything. So if I switch over to JavaScript mode, however, this kind of goes a little level deeper, and I can zoom in on the code here, and let me look for this line right here. Let analog 03 equals pins.a3.analog read. If I look in the Explorer, these are actually all of the little pieces of code that make up this MakeCode Arcade program. It's not just that blocks that we normally see. There's that blocks code, but here's the same code in JavaScript. And if we look down here, you'll see I've got the feather extension that shows me that that extension is loaded. And when we look at the code for that feather extension, we can see here's where pins are being defined. So you can see I'm using A2. There's this constant called A2. That means that's a name that I can use in my JavaScript code, and what it's being shimmed to or sort of connected to is this call, which configures pin A3. So that's a little deeper than we normally go. But the sort of nice, neat resolution to that is by adding the feather extension and typing in that code in MakeCode, I now have a block that, even though I can't build that in the blocks mode, does define a variable called analog03 as the analog read for pin A3. So I could go in and do this for any pin. And then the place that I'm using that, we kind of saw that before, is this game update block. I'm setting the raw water counter value to whatever that pin A3 analog read answer is, which is, as it turns out, those 0 to 1023 values that we saw. So if I pop back over here, you can see that's how analog pin 3, oops, now I've done it. There we go. That's how analog pin 3 is reading out right there as I change the potentiometer. And so that pretty much wraps it up. Let me know in the Discord if you've got any questions or comments. And I will be putting out a guide for this, and we'll hopefully get the MakeCode blocks that expose those feather pins in time, that we'll be able to do it all as the blocks instead of Java. Someone asked a question over in the YouTube saying, do you use the potentiometer to adjust the humidity sensitivity of the potting soil? No, what I'm doing right now is I'm just testing. I won't use the potentiometer in the end. I'll actually use the 2 nails. So the 2 nails will be sitting in the soil like so, and we'll get a different analog reading between that space, essentially by lowering the resistance. More water will lower the resistance, and so we'll read a higher voltage. A drier soil will mean more resistance, and so we'll get a lower reading of that. So it's easier for me right now, while I'm prototyping the code and figuring out the logic, to use a potentiometer so that I don't have to keep putting the nails either farther apart from each other or have dry, medium, and very wet soil. So it's really just a convenience. And in the end, I'm not going to plan to use the potentiometers on this program. But it is really exciting to get potentiometers working, and I think rotary encoders are on the way as well, so that we can use cranks and knobs and dials and things like that in the projects right inside of MakeCode Arcade. So yeah, FX Music says that's a cool project. Maybe I can try this with some kids here someday. Yeah, these are this is a really popular project with kids for sure. I've actually done some other. I won't grab it right now, but I've done some other plant. I built a robot that waters plants based on this same principle a number of years ago, and it was really popular with kids. I took it to like a mini maker fair thing that Barnes and Noble did, and kids were fascinated by the robot that waters a plant. So look for that. I'll be working on the Learn Guide, and that should be coming out soon. And I want to thank you again for stopping by. So for Adafruit Industries, I'm John Park, and this has been John Park's Workshop. Bye-bye.